Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 4-5 on isosceles and equilateral triangles. We have several important vocabulary and theorems to go over today, so let's go ahead and get started. We'll begin with all the different parts of an isosceles triangle. So you have three angles, of course, and you have three sides because it's a triangle. An isosceles triangle has two legs that are the same distance. So those are called legs, and the other side of the isosceles triangle is called a base. So you have two legs and one base in an isosceles triangle. The legs come together to form what's known as a vertex angle. The other two angles are known as base angles. So here are the base angles. So a vertex angle and two base angles, two legs and one base. The isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite to these are congruent. So these two sides are congruent, which makes these two angles also congruent. And then the converse of the isosceles triangle theorem says the opposite. If you have base angles that are congruent, the sides opposite them are also congruent. And our third theorem with regards to isosceles triangles, it says the red segment here is the bisector of angle A. Remember that to bisect means to cut something into two equal pieces. So this left side and this right side are the same as each other. They're congruent. And this red line that comes down at a 90-degree angle, it's a perpendicular bisector of the base. So CD here is congruent to DB over here. A corollary is a statement that follows immediately from a theorem. So they give you the information in the theorems, and then a corollary can be added directly onto it. We have two corollaries this time, and the corollary to theorem 4-3 says that if the triangle is equilateral, meaning all three sides are the same, it's also equiangular, meaning all three angles are the same. So angle X is congruent to angle Y, which is congruent to angle Z. The corollary of theorem 4-4, or the converse here, says that if you have all three angles being equal, it's called equiangular, the triangle is equilateral and all three sides are equal to each other. So side XY is congruent to side YZ, which is congruent to side ZX. And those are all the corollaries, and that's all the notes you should take for this lesson. Let's go ahead and get started on a couple of the practice problems. So this one comes from your practice, and it's about architecture. It says 17 spires, which are pictured here at the left, cover the cadet chapel at the Air Force Academy in Colorado Springs, Colorado. Each spire is an isosceles triangle with a 40-degree vertex angle. So this one right here is 40 degrees. They want you to find the measure of the base angle. Well, because we know that this is isosceles, we know that the base angles are also congruent. So we know that each triangle has 180 degrees. So if we take that 180 degrees and we subtract out the vertex angle that we know, we have 140 degrees left between those two angles. Since we know those two angles are equal, we can divide that by 2. And 140 divided by 2 leaves our base angles of 70 degrees each. And our last one for today is also from your practice. It wants you to, using the image above, if the measure for angle L is 58 degrees, what is the measure for angle LKJ? So if we draw this a little bit bigger over here, here we have our bisector. We know these are equal to each other. Because it's a bisector, we know according to the theorem that this one and this one are also the same. We know that this one and this one are also the same as well. it tells us that angle L is 58 degrees, and it's asking us for the measure of angle LKJ, which is this whole angle up here at the top. So 58 is actually a base angle, which means we know our other base angle is also 58. And remember that the whole triangle here is 180 degrees. So if we do 58 plus 58 plus that vertex angle, we will get 180 degrees. And when you do the math there, what you get is that the vertex angle is 64 degrees. Now let's try part B. Part B says that the measure of angle JKM, so this one right here, put that in red, this one right there, is 48 degrees. And it's asking us for the measure of angle J over here. So we know if the left side is 48 degrees, the right side is also 48 degrees. And we know that the base angles are the same. So if we have angle J plus angle L plus the vertex angle of 48 plus 48, that will equal our whole triangle, which we know is 180 degrees. So if we remember that J and L are the same thing, what we actually have here is 2 times that angle equals 180 minus 48 minus 48, which is 84. And if you divide that in half, what you get is that each base angle is 42 degrees. Good luck, everybody. I hope you guys do great. Have a wonderful day.